Hello, welcome back to Cinderella Math. Today is like a pre-calc slash trig lesson on double angle formulas. Alrighty, I would grab pencil, paper, calculator, like with a fraction button if you're allowed to use that. All right. Yeah, let's just go ahead and jump in. I am under a smidge of a time crunch, and I am doing this for a tutoring student, but I thought it would be helpful for just general. The tutoring student has 10 questions. I doubt I'm going to do all 10, but I'll try to do a good variety here. I do have the formulas. There they are. So most of the time, teachers don't make you memorize those, and you can just use a formula sheet. If you have one of those really uptight teachers that makes you memorize, well, go ahead and memorize them. You will notice that the double for cosine has three options. They're all fine. You can use them. You use whatever one is easiest. If I had to memorize one, I'd probably memorize the top one, but they all three are good. Alrighty, so let's just jump right in. Example one. If you are that student that sent me your homework, I'm gonna go down oh gosh. Yeah, I'm just gonna do a mix, I think. This will be number one off the paper if you are my student who sent me this. Cosine of theta is 2 root 2 over 3, and it tells us that theta is in between 270 and 360 degrees. That is telling us which quadrant theta is in, and that is important. So you know it starts at 0, here's 90, here's 180, here's 270, and then all the way back around is 360. So we're in here. We're in quadrant 4. So if we had to draw the triangle, we would draw it there. And the question on this one is find cosine of 2 theta. So we come over to our formulas and we look at the cosine 2 theta, and this is the one we have three options. The one that would be the easiest is just the middle one because we already have cosine. So if we use the middle one, we only need cosine. If you pick either the top one or the bottom one, you can still do it, but you're causing more work on yourself. So let's use that one. So cosine 2 theta, using the middle one, is 2 cosine square theta minus 1. Keep the 2. This is cosine. So we're going to do 2 root 2 over 3, and we're going to square it, and we're going to keep the minus 1. Keep the 2. 2 squared is 4. Root 2 squared is, this would just come off and be 2. 3 squared is 9 minus 1. So this is 2 times 8 ninths minus 1. If you're allowed to use a fraction calculator, feel free. This got a 1. This is now 16 because you just multiply right across, right across. 16 ninths minus 1. 16 ninths minus a whole, which would be 9 ninths, gives us 7 ninths. Okay, and again, there was other formulas to do that, but that was the easiest one because we had the cosine. So we didn't have to do extra work. Okay. Let me now do a cosine where we are going to have to do extra work. So again, if you're my student, this is going to be example 2, but if you're the student who sent me this particular worksheet here in November of 2025, this is number 7. So, but example 2 is going to be that we are given the tan of theta is 4/3. We are told that theta is in between 180 and 270. So let's figure out degrees, which quadrant that is. Okay, that's quadrant 3, 180 to 270. So we're in quadrant 3, and the question is the same as example 1. The question is still find cosine of 2 theta. Okay, so we have three options, but none of them say tan. So we're going to have to actually draw out this triangle and find some other information. So that's where the quadrant 3, or we're really supposed to write in Roman numerals, there we go. That's where that knowledge comes in. So go to your coordinate plane, draw a triangle in quadrant 3. So start at the origin. Let's go left and down. Boop, boop, boop. Always theta right there at the origin. We are given that tan is 4/3. So katoa, tan is toa. So this is opposite, this is adjacent. So from theta, go opposite. That's 4, make it negative because it's going down. And from theta, the flat adjacent is 3, make it negative because it's going left. So really this was -4 over -3, but negative divide negative turns positive. We need the hypotenuse. Pythagorean theorem back from high school geometry. You do the flat side square plus the other flat side square equals the hypotenuse square. So that's 9 plus 16, which is 25, equals hypotenuse square. Take the root, and that's 5. And you are going to leave that one positive. So the hypotenuse is 5. Now we're going to do cosine 2 theta. It does not matter which rule you want to pick here. It doesn't matter. So you have 3 choices. For kicks and giggles, I'll do the top. So it says cosine square minus sine square. So looking at this triangle, we need the cosine and we need the sine. So cosine is ka, so adjacent hypotenuse, and sine is so opposite hypotenuse. There we go. So I'm using the first formula. We need cosine square minus sine square. Well, we just said the cosine's -3/5 and square minus the sine is -4/5 and square. At this point, again, if you're allowed to use a fraction calculator, go for it. This would be 9 over 25 minus 16 over 25, which would be -7 over 25. Again, if you used one of the other 2 formulas, it should still have worked out to the same answer. It truly does not matter. I just did a different one that time to do something different. Okay, let's do a double sine. This is going to be example 3. And again, if you're my student who sent this in, I'm going to now do number 2 on your paper. They tell us cosine of theta is 13 over 20. They also tell us that theta is in between 270 degrees and 360. So that's back in quadrant 4. And they are asking us to please find sine of 2 theta. So if you come to our formulas, we only have one choice for this. We must do this one. So sine of 2 theta is 2 sine theta cos theta. We have cos theta. So this is going to be 2 something 13/20. We need to get sine theta. So let's come to our quadrants and draw a triangle in quadrant 4. So start at the origin. We're going to go right and down. There we are in quadrant 4, theta near the origin. They've given us the cosine. So cosine is ka. So this is A, this is H. So from the theta, adjacent is 13 positive because we're going right. And the hypotenuse is 20. We don't know this. Let's call it X. Pythagorean theorem. Flat squared plus flat squared is hypotenuse squared. Let's just work that out. And that's x squared equals, I did this all earlier. Let me see here. I've got the work. 231. Let me just check that. Yes. 231. Take the root, take the root. That's not a perfect square. Let's see if it breaks down. I mean, it's not even, so I'm going to try a 3. It's 3 times 77 and 7 and 11. There's no partnerships. There's no squares in there. So we're just going to let this flat side be root 231 and negative because it is going down. All right. So now what is the sine of this angle? Opposite is negative root 231, and adjacent sine is so, right? Sorry, so opposite hypotenuse. So opposite is that root, and hypotenuse is 20. So that's going in. For sine, there's an invisible 1. 2 times this root times 13. Well, 2 times 13 is 26. Make it negative because there's the negative. Keep the root. 1 times 20 times 20. So that's 400. This is even, so we can divide by 2. Divide by 2. So negative 13 over 200 and keep the root. That is the answer. It's ugly, but that's okay. Let me do one more sine, and then I'll do a tan, and then I'm going to call it a day. Okay. One more sine. This is example 4. If you're my student that sent in these problems, this is number 8. They tell us tan theta is negative 2 root 5 over 5. Always put your negative on the top. It just makes life easier. And they say theta is in between 630 degrees and 720. All right. If we think of our grid, those are not on there. So subtract a circle to find a coterminal. So subtract a circle, which will put us, I know this one's 360, and subtract here 270. So this is, here's 270, here's 360. We're in quadrant 4. We are allowed to do that. Just if it's too big or too small. Too big, subtract a circle. Too small, add a circle. And the question here is find sine 2 theta. So we have to use this formula. So we have sine 2 theta is 2 sine theta cos theta. And we don't have any of that. We have the tan. So we need to come over to our grid. We said we're in quadrant 4 after we subtracted circles. So let's make a triangle in quadrant 4. So go to the right and down, connect. There's theta, there's your right angle. Tan is TOA. So this is opposite and this is adjacent. So from the theta, opposite is negative 2 root 5. Adjacent is 5. We're missing the hypotenuse. Pythagorean theorem. Flat square it plus flat square it equals hypotenuse square it. So that's 25 plus negative 2 squared is 4. Root 5 squared, that knocks off, and that's just 5. So that's 25 plus 20. 45 is h squared. Take the root, take the root. It's not a perfect root, but see if we can get a root out of it. That's 9 times 5, which is 3 times 3. So it does have a 3 in there, and the 5 would be back under. If you break down your roots different than me, that's fine. You should still get 3 root 5 for our hypotenuse. Okay. Now we need sine of this angle. So sine is so. Opposite is negative 2 root 5. Hypotenuse is 3 root 5. The root 5s would cancel. So we are going to keep the 2. Sine is negative 2/3. Okay, now we need cosine. Cosine is ca, so adjacent from theta is 5, and hypotenuse is 3 root 5. So it's okay to keep the root in the bottom for now, because that's not our final answer. Okay, now I'm overworking the pink. 2 times negative 2 times 5. So negative 20. 1 times 3 root 5. So 3 times 3 is 9 root 5. If you have a teacher that's not uptight about roots on the bottom, that's probably fine. But most teachers are uptight about roots on the bottom. So we'll fix it by timesing by that root. So I'm going to switch to a black pen. You're going to times by the root to get him off. That's going to be negative 20 root 5 over 9 times 5, right? Because root 5 times root 5 is really root 5 squared, which will bust out. So that's negative 20 over, excuse me, root 5 over 45. But then, sorry, this reduces. You can divide by 5, divide by 5. So that's negative 4 over 9 root 5. That's probably the best answer here if you have a teacher that wants the roots out of the bottom. Okay, let's do a tan. So this is going to be example 5. If you're my student that sent this in, this is number 6 on your paper. So example 5 here tells us that the cosine of our angle is 3/5, and our angle is in between 0 and 90 degrees. So that's quadrant 1, 0 to 90. And they are asking us to please find tan of 2 theta. So we come here, we only have one option for tan 2 theta. So let's write that down. We need 2 tan theta over 1 minus tan squared theta. Okay? And so we need tan. We don't have it. We have cosine. So let's draw our triangle in quadrant 1. Start in the middle, go right, go up. There we are in quadrant 1. There's theta. They gave us cosine. This is ka. So this is AH. So from our theta, adjacent is 3 positive and hypotenuse is 5. We don't know this. Pythagorean. Flat squared plus flat squared is hypotenuse squared. Just solve this out real fast. I'm down there in red. And this comes out nice. This is just 4. So we will take that positive because it's up. So we need the tan of this angle. Tan is TOA. So from this theta, we go opposite, adjacent. So our tan is 4/3. Now we're ready to actually solve. We have 2 times tan, so that's 4/3, over 1 minus the tan, so 4/3, squared. And again, if you have a fraction calculator and you're allowed to use it, go for it. I know this is a 1, so that's 8/3 over 1 minus 16/9. 8/3, 9/9 minus 16/9. 8/3 over negative 7/9. We keep, we change, we flip. 8/3 times 9 over negative 7. That's 72 over negative 21. We can divide by 3. That's 24 over negative 7. Put the negative on top, it'll look better. Answer. Okay. Again, I do all that fraction work because honestly, for me, I like fractions. They don't scare me, and it's sometimes faster than getting a calculator. But if by all means, if you're allowed a calculator with a fraction button, go for it. I've got time to do one more. Let me do one more cosine. So this is going to be example 6, number 9, if you're the student that sent me this paper. Oops, example 6, sorry. It says the sine of theta is 15/17, and theta is in between 90 degrees and 180. So think about where we are here. Here's 90, 180. We're in quadrant 2. And they do want us to please find cosine of 2 theta. This is the one that's probably the hardest because you have the most choice. Those are our 3 options. We have sine. So just pick the one with sine. So we don't actually have to do work here. We don't have to draw the triangle. Pick that one. So we're going to pick the third one down, 1 minus 2 sine square. Put this in. So that's 1 minus 2 times 15 over 17 square. If this point, if you have fraction calculator and you're allowed to use it, just do it. Otherwise, 1 minus 2 times 225 over 289. There's a 1. So that's 1 minus 450 over 289. The 1 can turn into 289 over 289. Okay, subtract, and we get, what, 450, 289. negative 161 over 289. Again, I did that all by hand. By all means, you do not need to. And again, we saved work on, we did not have to do the triangle step because we picked this formula because we already knew the sign. You could have done the other ones. It would have still worked. And maybe for kicks and giggles, we just do one. But look how, if I pick the top one, I'm going to make more work on myself. Let's pick the top one now. Same problem. And it will still work. It's just going to take longer. So this one. Well, I have the sine, I don't have the cosine. So I'd have to draw the triangle into quadrant 2. So go left, up, boom, boom. They gave us sine, so this is OH because sine is so. So opposite is 15, hypotenuse is 17. We have to find that. Flat square plus flat square equals hypotenuse square. So see, it's already more work. 225 plus x squared equals 289. Subtract. X squared is 64. Take the root. That does come out nice. X is 8. Negative 8 because we're going left. Okay, and we need the cosine of that angle. So adjacent is negative 8. Hypotenuse is 15. Okay, now I can do the top formula. So cos square minus sine square. Okay, cos we just got is negative 8/15 squared minus sine they gave us in the problem. 15 over 17 squared. We could also see that from the triangle, but they gave it to us in the problem. Now go. That's 64 over 225 minus 225 over 289. And, ooh, gosh, you'd have to get a common denominator. Oh, wait, I messed up the cosine. Sorry. The cosine is not negative 8/15. It's negative 8 adjacent hypotenuse. There we go. Okay, now do that formula. Top one, sorry. Cosine square minus sine square. Top one for cosine. The one in the green box. So now let's go. Negative 8/17 squared minus sine, they gave us in the problem, 15/17 squared. So that's 64 289s minus 225 289, and then you'd still have to crank that. Whoops. 64 225. Negative 161 over 289. So same thing, but this required more work. This required us doing the triangle, doing SOHCAHTOA, where if we just did the one with the blue star from the get-go, we didn't have to do any of that because they gave us the sign. And the very, very first problem I did, example 1, we did the middle formula because they had given us the cosine. So be smart there. Pick the one that requires the least amount of work for the cosine. You got 3 options. It doesn't really matter. They will all work. But why not make your life as easy as possible? If your question is the sine, you don't have an option. You have to do the top one, the only option. And if your question is the tangent, again, you do not have an option. You have to do that one. Okay? All right. I hope this was helpful and you're having a great day. Bye-bye.